morning, wherever you're calling from. I'm very glad that you are here today. My name is Deji Akamalafe. I'm the practice lead for Microsoft Application Virtualization here at VMware. What that means to you is I know a few things about what to do and what not to do when you try to virtualize your Microsoft applications on vSphere, specifically Microsoft SQL Server, which happens to be the number one most virtualized application on the vSphere platform. Correspondingly, VMware and vSphere also happens to be the number one destination for most virtualized Microsoft SQL servers. I've been at VMware for a while. When I began to do this about 12 years ago, I used to explain to people like you what VMware is, what virtualization is, what's an hypervisor. That's been a long time ago. Now we don't do that because you, as you're sitting here listening to me, most likely know as much as I do about vSphere virtualization, and most likely you do know more than I do about SQL Server. What I know and what I bring to the table and what I talk to customers like you about. 12 years ago, 15 years ago, when we started talking about virtualizing Microsoft critical applications, a lot of sysadmin, database architects, and data professionals were like, "No, what's that about?" Virtualization used to be experimental, and nobody trusted that platform to sustain their most important applications. We've come a long way. When I used to do this, I used to tell you about the nitty-gritty and the minutiae of virtualizing and virtualization, the concept, the 101. We've come a long way. So today we'll be talking about the things we no longer talk about. I'll mention them briefly, and we'll come to the now, the questions worth asking when you're thinking about your mission-critical Microsoft SQL Server. And I'll take you from there to how you can get to the target destinations. And then I'll provide some insights, references, and some collaterals. What I want to be able to do is after this 1 hour you're spending with me, you get enough information with enough references and guideposts and pointers to how you can learn more about what to do and what not to do when you virtualize your Microsoft application on the vSphere platform. And you will see very shortly why we say hybrid or on-premise, it doesn't really matter. So let's get going. These are questions we no longer ask, and these are questions that I no longer have to address in sessions like this. Oh yeah, we don't trust the hypervisor, we don't trust virtualization because of application integrity. We've been able to demonstrate over the years that whether physical or virtual, applications don't discriminate. If your application knows, if your SQL Server knows that it's running on a virtual platform, you've done something wrong in your configuration and tuning of that virtual platform. We remove that distinction or that differences many years ago. Reliability and availability, at the beginning, everybody was worried. Oh, it's just a bunch of files. It can get corrupted, it can get deleted, and then what do we do with our SQL Server or with our databases? Well, is virtualization stable enough for my mission critical applications? Yeah, well, we've proved that. This is why today virtualization is actually the first point of call when you want to do anything with your SQL Server. You have to now justify why you would need a physical hardware for your SQL Server. So it is now the standard because we've been able to prove the reliability and the availability of your SQL Server on the virtual platform. Platform security is another thing that we used to talk about. I used to spend hours just talking about this alone. Is it secure? Well, it's not any less secure than a physical server. What about stolen VMDK? We crossed that bridge several years ago. Now we have VM encryption, we have encryption at rest, we have storage data encryption end-to-end, where the way we implement VM encryption on vSphere, if you were able to even steal the VMDK, you take it out of that environment, it's useless to you because you can't even access the data on it. So we answer that question. Can it scale? Can it handle my beefy, large, mission-critical OLTP 24/7, 99.9 million nines? Uptime? Yes. Because unless your single Microsoft SQL Server instance typically has more than 768 CPUs or 24 terabytes of memory, well, your SQL Server can fit into a VM on the VMware vSphere platform. So again, we answered that question. Is it costly? Is it more? Is it cheaper? Those are topics that I personally do not get into, but over the years, it's been demonstrated that virtualization not only improves consolidation, the density, your ability to use that physical hardware more densely than you would otherwise use if there were no hypervisor in between, the ability for you to rapidly provision new VMs, install your SQL Server on it, or install deploy a fully installed SQL Server through a template. And we've also demonstrated that you get to utilize the resources on that physical hardware more densely to the maximum. So yes, these are questions we no longer ask. I have to run through them just to remind you of how far we've come in answering the question, is SQL Server a good candidate for virtualization? You're not asking that today. So let's go to what do you ask? What are people thinking about? The cloud, everybody agrees, is a destination for SQL Server workloads. There's nobody in this room who would disagree with that. So we'll move on. How do you get there? It's now the question. What will it look like when you get there? Is a question. How do you make it work for you, for your business, for your need? These are the questions that agitate the minds today. And as data specialists, data architects, data professionals, you want to be sure that you understand how the virtual infrastructure, whether the cloud, on-premise, hybrid, whatever you call it, if there's an hypervisor between the hardware and your application, you want to know how you can make that work for you and your customer and your business owners. We're going to spend the next few minutes just talking about the construct of cloud and whether or not the VMware Cloud is available and is scalable and can provide what you are looking for. VMware Cloud, when you think about it, is not just a cloud provided by VMware. We have almost the entire ecosystem where you can have your cake and eat it. So let's say on-premise, you've standardized on VMware vSphere, and now you are embracing the cloud because your CEO, your CFO, your CIO, your CTO all played golf with somebody and they came back into the office and told you the cloud it is. You have vSphere on-premise. You are in good hands because even if the CIO, the CTO, or the C-level person decides that, okay, no, we want to use AWS. In AWS, you will find the VMware cloud infrastructure. Microsoft Azure, you will find the VMware. Google, IBM, Oracle, everywhere there is VMware vSphere present in that hybrid cloud composition. And it's all global. It doesn't really matter which of these you standardize on, which of these vendors you prefer. What matters is the consistency, the ease of moving from wherever you are today into that target cloud infrastructure. You have access to all the partners, IBM, Azure, Google, Alibaba, we are everywhere. Now, you don't have any, what I would say, conundrum in saying, okay, do I now have to recompose my applications, my VMs? Do I need to relearn new tools? No. If you are already familiar with the vSphere infrastructure, the other hybrid cloud environment that you are going to look exactly like what you are familiar with. The same pane of glass, the same interface, the same way of doing things. All right, that's a high-level introduction to where your hybrid cloud journey can begin and go. So let's talk about, again, one of the questions that continue to agitate the mind today. The elephant in the cloud, licensing and supportability. Will this cloud environment that I'm going to be supported by the application vendor or by the cloud provider? There is no change required to your on-premises licensing for SQL Server. There is no software assurance requirement, but it is recommended that you have one. We won't get into software assurance and what that gives you, but I'm sure you're very familiar with that. Moving from your on-premises into your hybrid cloud environment should not put any constraint license-wise on you. It is fully supported to run. SQL Server is fully supported to run in any virtual environment. There is no if, but, or exclusions. There's no limitation and there's no special certification for VMware Cloud on AWS, Azure VMware Solutions, or Google Cloud Engine, or anything you want to do. So let's get a little bit into the licensing aspect. I'm going to use AWS as an example because much as we like it, that's what most people are familiar with. The same construct also can be extrapolated and applied to other hybrid cloud service provider. In a specific scenario, in your customer scenario, you own the licenses to your Microsoft Windows Server 2019 or previous. Well, you want to move it to a hybrid cloud infrastructure. If you got the license before 2019, October 1st, 2019, you can leverage the existing license. After 2019, you must purchase new licenses. And this is not because you're virtualizing on vSphere or anything. This is a Microsoft requirement. It's not because you're virtualizing on AWS. This is a Microsoft requirement, and it applies to everybody generally. I am using AWS just as an example. For SQL Server, the same thing is almost identical. Before October 1st, 2019, you can bring if you purchase those licenses before that date, those licenses are portable. After that, you can purchase new licenses from Microsoft or from VMware. And you want to move from VMware Cloud or from on-premises to AWS, you can do either leverage your existing licenses using the license mobility by if you have software assurance, or you buy new licenses on or after October 1st, 2019. That is at a high level the licensing requirement for moving from your SQL workload from on-premises to any of the target cloud. You will notice that I provided hyperlinks in these tables so you can read more about how this works. We don't have enough time to dig deeper into the minutiae and the nuances, but this is the general overall picture. All right. Now, let's talk about how do you now get from where you are today to your target destination. Again, pardon me, because we have so many partners in the ecosystem, it isn't practical for me to mention every one of them. So I'm using AWS as an example, only as an example. Your application tiering falls into mostly three distinct categories or tiers. You have the tier 1, which are the high performance, the high availability, and the ones that can cost you the most pain if they don't stay up. And then you have the tier 2, which you do for capacity and for cost saving. You can consolidate as many VMs onto one physical host as possible. You don't really care much about performance. And then there's a tier 3. This usually what you will call your pre-production dev test environment. These are the general overall overview of what these tiers look like. Now we look at SQL specifically. In the tier 1, you will usually have the OLTP type of workloads with high IOP requirement, TPCE characteristics. The data warehouses will fall into tier 2. What you use for your backup, restore, database refresh will fall into tier 3. I think we can all agree that this is a very applicable or a good classification. Now, how do you move any of these, each of these, from your on-premise, your current existence today, to the desired end state? Again, hybrid or on-premises. We've just told you that there is no differences. There's no difference between the two. What your vSphere infrastructure looks like on-premise is what it's going to look like in the cloud. You have multiple options of moving from current state to the target state. And this reflects what we just mentioned about the tiers. If it's a tier 1 mission critical application, there is a different approach. If it's like a tier 3 that you don't really care with about the uptime or the performance, there's a different approach also. We've always had the live code migration of VMs and the applications inside the VM for a very long time. We still have that. And that is usually the first point of call. The live migration is what a user does by right-clicking on the VM and say, I want to migrate this VM to another destination. You can right-click on the VM in your on-premise infrastructure and say, move it to the cloud, even while the OS and the application is still running. This leverages long-distance cross vCenter vMotion. You cannot schedule it, and you only use it for special use cases. For example, the primary node of your always-on FCI or AG. We have the hybrid cloud extension. We call it HTX. This is for massive bulk migration. It's based on vSphere replication. It requires a restart of the VM, unlike the live migration. The live migration, we are moving that VM while it's running. With HCX, we require you to restart the VM multiple times. It's vMotion based. vMotion is that technology I just mentioned, where we teleport a VM from one location to another without dropping the transactions. With HCX, you can do vMotion one VM at a time. The VM will still stay online. This is all. You also have the user initiated or the scheduled part of HCX. It requires that you have a network bridge or extension between your on-premise and the cloud infrastructure. You can do that with a VPN, or you can provide L2 VLAN stretching. Again, next slide, I'm going to use AWS as another example, and I'm going to give a more detailed overview of the process. Here is Microsoft Server workload on VMware Cloud on AWS. Here is how we're going to get from one place to another. For standalone Microsoft SQL Server on VMware Cloud, this is what the picture looks like. And this is what you get with your hybridity from on-premise, your data center, where you have a vCenter server, or multiples of it, and your SQL Server workloads running, you have a network connection between that physical or logical data center and the VMware Cloud on AWS infrastructure, which is on AWS away from you. You have a vCenter in there, again, the same thing that you have on premise, and you can use the resources provided, native AWS services provided through this VMware Cloud on AWS. This is one of the benefits of hybridity. In this state, what I'm showing you, there is continued coexistence between your on-premise SQL Server infrastructure and the VMware Cloud on AWS in steady state. You can move anything back and forth between these two data centers while you continue to have access to the native AWS services on the VMware Cloud on AWS side. We're going to simulate or discuss a little bit of workload migration. We will caution, of course, that before you decide that you want to move your VMs from your on-premise infrastructure to VMware Cloud on AWS or Azure VM solutions or Google or anything, pause and think. Normally, as a DBA, as a data professional, as a data architect, you, rightly or wrongly, have this tendency to allocate as much resources as you can get your hands on to a SQL Server instance or multiple instances of it. This is how we are wired. We want to give SQL Server as much resources. Now, because on the cloud side, the public hybrid cloud side, you are paying for allocation and occasionally consumptions. Do you want to move a SQL Server sitting on a physical or a physical server or a VM with, let's say, 64 CPUs to a hybrid or public cloud infrastructure with that many CPUs? When DMV queries could show you that over the past 12 months, those 64 CPUs have been used at a margin of maybe 40% consistently. Here is where the opportunity for you to right size that SQL Server comes in. And this is where some of the savings of embracing hybrid cloud or public cloud comes in. On your data, in your data center, on physical server, you are paying for that physical, you paid for that physical server, and you don't continue to pay over a period of time. So whether you waste resources or you use them, it doesn't really matter much. When you get to the cloud, it does matter. These are some of the good architecture and planning operations, considerations that you have to factor in before you even begin the move. The risk assumptions: if you can't afford to have the VM down for any period, a long period of time, then your approach to moving will have to be factored in. Are you going to do the live migration, or are you going to do the scheduled HCX bulk migration? You have to also revisit your current architecture. You have a plethora of SQL servers siloed on physical server or on small VMs. Do you want to consolidate multiple instances into one large VM? Do you want to reduce some of the separations? Do you want to change your overall backup structure or plans? These are things that you have to deal with before you even begin to do the move from your physical to your virtual environment, to your cloud environment. high-level introduction to things that you have to consider. Now, we're going to get a little bit technical. These are questions that you ask. How do I make it work for me? Please, before you begin your journey from on-premises to the cloud infrastructure for your SQL Server workload, please disable CPU hot plug. CPU hot plugs is an administrative convenience that lets you add additional CPUs to a VM without powering off that VM. SQL can instantly, reconfigure, begin to use the CPUs. If you had done what I mentioned in previous slide, if you had right-sized, this won't be a necessary feature. It also disables VNUMA, virtual NUMA. SQL does like virtual NUMA. The enhancement and the performance increase in being able to leverage virtual NUMA is very, very good for SQL. If you enable CPU hot plug, you take that away for administrative convenience at the SQL Server's expense. Please always check that you don't have limits on the VM that you're moving. This is one of the main cause of pains for people virtualizing SQL Server today. They use a template where a limit has been set. A limit is a limit. You cannot, the VM, the running VM cannot exceed whatever you set on limit. I've seen people use templates where a limit of 8 gig of RAM has been set by the vSphere administrator to discourage abuse. They use that template to deploy a VM for SQL Server that requires 64 CPU and maybe 300 and whatever gig of RAM. A limit has been set on that RAM for 8 gig. It doesn't matter whether you add 1 terabyte of RAM to that VM, unless you remove that limit, it will only be able to address 8 gig of RAM, period. When you want to allocate CPUs to your VM, please first understand the NUMA topology of your physical hardware. Base the allocation on that topology. For example, if you have a 2x20 physical ESXi host and you want to give your VM 24 CPUs, for example, vCPUs, for example, please base it on a 2x12 topology. Try to mirror what's on the underlying physical hardware. Anything else will result in suboptimal performance. It's okay for you to use memory hot plug. We always recommend that you set reservation for memory for the important SQL Server VMs that you want to deploy. This helps you in the case where you are over provisioning resources, you are over allocating memory in a vSphere cluster. The VM that has memory reserved will always be entitled to that much memory. So your important SQL Server VMs will not be contending for memory with other noisy neighbors if you set reservation for that memory. You may find some things on the internet that tells you to not use VMXNet3 NIC for your SQL Server. Please disregard any of those things. And if anybody asks you why you're disregarding it, be sure to mention my name. There is no network card optimal in the vSphere environment for SQL Server beside VMXNet3. Do not use anything other than VMXNet3, regardless of whatever you read anywhere else. On VMXNet3, enable RSS, receive site scaling inside Windows. And this is why you can't use anything other than VMXNet3, because VMXNet3 is the only network card in vSphere that supports receive site scaling. Receive site scaling lets Windows use multiple CPUs to service network requests. If you don't have receive side scaling enabled, typically Windows will pass all those traffic over one CPU. And regardless of how many you have in there, that CPU will likely be overworked, and you will be getting network packet drops inside the guest, which doesn't make it onto the VM kernel, which your vSphere admin cannot see, and your SQL Server will be stressing, and your vSphere admin will be telling you, I don't see anything. Consider using L2 VPN and hybrid cloud extension, stretched-based port groups in your vCloud environment, regardless of where it is, AWS, Google, or wherever. The storage-based, I'm sorry, one too many. RAID 1 and at least one failure to tolerate is what we recommend for your SQL Server in your hybrid environment. On-premise, if you're not using vSAN, this doesn't apply. Every hybrid cloud incarnation of VMware Cloud is based on vSAN. So this SPBM is important. Always use multiple PV SCSI controller. VMware Virtualized SCSI controller is the only recommended SCSI controllers for all Microsoft SQL Server data files. Your transaction logs, your TempDB, your data, everything back in that. Please use PV SCSI controllers only. The only exception is for the OS disk, which can be on the default LSI Logic SAS. Don't forget to tune the PV SCSI queue depth. Your hybrid cloud provider will tell you if they let you change this. They will tell you what to set it to. If they don't let you change it, they would have changed it for you. But always ask to know if the queue depth has been adjusted. Use multiple VMDKs, multiple disks. When you're clustering, please do not use SCSI bus sharing set to virtual in a VMware Cloud environment. Set it to physical. All right. What are the higher availability options available to you in a VMware Cloud-based hybrid cloud environment? Native, you have the long-running, well-known vSphere HA, which helps protect our VMs. If a host on which a VM resides becomes unavailable, vSphere HA will power that VM on another host very quickly, reducing downtime. Always use stretched cluster and try as much as possible if the option is available. Most hybrid cloud provider has this, but ask availability zones, multiples of them, please. Do not put your egg in one basket by using only one availability zone. Try and get multiple, not only for DR purposes, but also for high availability purposes. We support SQL Server always on AG without restriction because there's no shared disk required. You can use SQL Server replication. You can combine it with the on-premise VMware Cloud and your on-premise your VMware vSphere environment and your VMware Cloud on AWS on Azure. So you can have one node on-premise and another node in the hybrid cloud of your choice. FCI, we support FCI. We support it on stretch cluster. You can combine it with AG. In order for you to be able to do FCI in VMware Cloud, you have to set the VM to the VM virtual hardware to at least 11. Now, please, this is very important because if you are moving a VM that you deployed maybe on vSphere 5.0 or 5.5, and the hardware version is, let's say, 10 or lower, and you move into your hybrid cloud and you want to do clustering, you will see that it will fail. And the only reason it will fail is because the hardware compatibility is not set to where it should be. For FCI, we always require physical mode SCSI bus sharing. Yes, you can do FCI with VMDK today. There is no option for RDM in vSAN anyway. And if you remember that vSAN is the underlying storage in all of VMware Cloud, and vSAN only does VMDK, and I'm telling you that you can do FCI, then it's logical to infer that yes, you can do FCI with VMDK today. All right. This is what a little bit of what I mentioned about clustering. Here is an example of always on availability group with a stretch cluster. I won't dwell much on this in the interest of time. You're going to get these slides, and what you see here will make more sense when you tally it with what I've been telling you before. So let's do a quick round on the configuration itself. The standalone SQL Server is an easy call for VMware Cloud. You can use live vMotion, you can use HCX, you can use even a copy. You can take the VMDK, power off the VM, move the VMDK to your hybrid cloud environment and register that VM over there. There are multiple ways you can skin that. For clustered SQL Server, we will always recommend that you try to migrate the secondary or the replica first. Once the replica gets over to the hybrid cloud environment, then you can fail over and make it the primary, and then move the one that used to be primary over. This way, you are not impacting the primary with whatever you use for the move, either ACX or vMotion or live migration. After you've migrated your VM, some things may look funky to you. We try to avoid this as much as possible. Let me give you an example. In the good old days, when you were moving from physical server to the vSphere environment, you usually use what we call P2V. At the end of that exercise, you have a VM where all the disks attached to the physical server end up on either one data store or one SCSI controller, and then everything will start failing. And people were attributing that to, see, we told you virtualization is not stable. We don't have that issue anymore, but there are some things that may not work well, and you have the duty of double checking them post migration before you declare the migration to be successful. It can be experiencing latency. One of the root causes is usually the mismatch between the physical NUMA topology and the NUMA topology or the allocation that you've made for CPUs for the VM. It is very important that this matches what you have on the ESXi host in your hybrid cloud environment. When you are clustering, we always recommend that you use anti-affinity rule between the clustered nodes. This is both for on-premise and now for the hybrid clouds that are becoming very popular. If you don't use anti-affinity rules, what can happen is that the two or more nodes in the same SQL cluster can land on the same ESXi host. Now imagine that that host becomes unavailable. You've just impacted multiple nodes of the same cluster. By implementing anti-affinity rule, you avoid this possibility. Your database replication may stop working. This could be attributed to a lot of things, to many things, but I'm pointing it out so you can make sure you include this in your post-migration checklist. I'm breezing through this because I intend at this point to remind you that we have very comprehensive documentation of everything I just mentioned to you. We try to put as much information as possible in our best practices guide, and if you've seen it, you will know what I'm talking about. Every one of these things that I've mentioned to you and more, including explanation that I just glossed over, in the best practices document, several of them that we created for Microsoft SQL Server, not just for on-premises, but for the hybrid cloud infrastructure. Please do read it. I have many of these also included in this deck, and you will get this deck through SQL Saturday.LA. So you can take them home, you can give them to your vSphere administrator if you don't get to touch vSphere, and tell them this is what VMware says it should be. I have a lot of references here for licensing because licensing is a very, very delicate topic, very interesting. And I've sourced and documented most of the references that we have for this topic. Support, you're guaranteed, you can rest assured that all of this is supported by both Microsoft, the hybrid cloud provider, and VMware. Who takes lead in one or the other scenario is a product of the support that you have with each of those vendors. Your on-premises support contract do not necessarily extend to your hybrid cloud environment. So you have to ask your vendor, both Microsoft and the hybrid cloud vendor. If you're not sure, go back and ask Microsoft, because we're here. I'm here talking to you about Microsoft SQL Server. Microsoft is the final authority on what the licenses should be. Typically, your hybrid cloud VMware cloud provider is the primary support contact. The reseller continues to be, the reseller or VMware or anybody that you bought this from continue to be the primary for on-premises support. If you have OEM Cloud Reseller Bundle, you also get support from them. Your Microsoft Premier Support contract is a glue that ties most of this together. Whatever statement, whatever agreement, side agreement, or included agreement you have with Microsoft prevails at the end of the day. Direct, independent. Yes, sir.
There is a question. I think I maybe even have it, but maybe it's not up to date. So the question is, maybe I'm missing something. Is there a best practices guide publicly available? If so, where? If I remember correctly, VMware has it best practices that basically includes, I don't know if it's all stuff that you mentioned, but some of the stuff definitely you mentioned there.
Yes. So here is where you get everything about best practices. I've included this link here. Whatever you're looking for is included in one of these links. The best practices itself, if you just Google Microsoft SQL Server, VMware best practices, you will get the latest best practice guide we have for SQL Server. Do we have any more questions?
So far, no.
Okay. to wrap this up, you can see that I did not deliver or present any earth-shattering new information to you today, because there is none. The VMware infrastructure that you have on premise on which you run your SQL Server today looks exactly identical to the one you will find in any of the public hybrid cloud infrastructure, from Microsoft to AWS to IBM to Alibaba to Google to everybody. The underlying infrastructure is the VMware Cloud Foundation. The look and feel are the same. Your journey from on-premise to your cloud environment is much more simplified, because there is no recomposition necessary to move your running SQL Server workload from on-premises to your virtual environment. This is why we no longer ask the question, is it good enough? The on-premises infrastructure has been demonstrated to be good, and not just good enough, but sufficiently good, performant, and even at times equal to physical experience. And because this same technology is what powers the hybrid public cloud, the answer for you also is yes, it is good for your most performant, for your most hungry, for your biggest SQL Server instance. So I'll stop here in case anybody has any question. I get paid by the number of questions you ask, by the way. So please ask questions. And if you don't have any, I hope I've been able to contribute some things to your knowledge repository today. My name is Deji Akamolafe. I am available at deji@vmware.com. If you can spell my first name, you can always reach me. And the only thing I do for VMware is help people like you understand what to do and what not to do when you place your Microsoft SQL Server on the vSphere platform.
Okay, I need to unmute myself. Stupid. Recommendations for hyperthreading.
Okay, hyperthreading for SQL Server is beautiful, but please do not size your vSphere or your VMs based on the number of hyperthreads. So what happens is when you enable hyperthreading, you see twice the physical cores. So let's say you have 12 physical cores, you will see 24. Both Microsoft and VMware support over provisioning of up to 2-to-1 ratio. Now, what some people do in the past anyway is, yeah, Microsoft supports 2-to-1, VMware supports 2-to-1, and they had already enabled hyperthreading, and they double up on the hyperthreaded count. So now they are allocating 48 CPUs to their VMs on a hardware that has only 12. So please do not do that, but please definitely enable hyperthreading. You don't get licensed by the hyperthreads. You get licensed on the physical core. There is no, well, I should say, Spectra and these Intel CPUs and all the bugs that have been addressed over the years. If you are in the shared environment, that may be a concern. If you are in your own private environment, it shouldn't be a concern, because you should be able to trust all your workloads in your environment equally. So with that caveat, I encourage you to enable hyperthreads after assessing your risk factor.
A question for you, Deji. From my experience with VMware, I remember power plan is usually on power saving.
Yes.
What's the point? If VMware
Okay.
is like servers, and servers, you only care about performance.
Yes. You won't blame VMware alone for this. The
And
industry,
Microsoft there as well, yeah.
the industry kind of got together and said we want to save the planet, and we're going to default to um, balanced power saving because we want to be green. Good for the environment, very, very bad for your SQL Server. The first thing you have to do, you want to do when you are virtualizing your SQL Server is one, ask your vSphere admin what the power plan is. If it's not anything OS controlled or high performance, please encourage them to read the best practices. OS control just cedes the power control to ESXi. High performance, just lock it into high performance. You want to run everything for your SQL Server at high performance, including Windows. It is especially insidious in Windows. So it's one of the first things that you have to go fix for your SQL Server if you're not already doing that. You don't want your SQL Server running on when Windows is doing core packing or trying to save energy. It's not to your advantage, and SQL doesn't like it very much.
Got it. So sounds like this is probably not going to change by default. The default isn't going to change.
Again, the saving the environment and the I think the logic is that most applications don't require high power or high performance, but
Okay.
yeah, definitely not SQL. And since we are here talking about SQL, high performance everywhere, please.
Got it. Tajid, thanks a lot for the session. For
My pleasure.
attendees, there is a QR code for the feedback. You can scan it with your phone. It will take you to feedbacks, and this way you can provide Deji and us a feedback so we can improve session or quality or whatever you think we need to improve.
I thank you very much for giving me the opportunity to speak with you. I hope you took something away from here. And if you do have questions, please reach out to me.
Sure. Thank you, Deji. Thanks to all the attendees.